Okay, hi everyone. So today we are working on absolute value problems. Now, most of us already seen absolute values, and absolute values look like these lines, and we'll put X there. And this idea is, here's the main idea. It's how far from 0. It seems kind of like a weird idea, and like, why would we call it that? Like, who cares about 0? But it's more like it applies in physics and other ways, because if I say, let's look at the number, let's look at a number line here, and what if I write 3? Well, how far is 3 from 0? Would you read that's 1, 2, 3, 3 spaces? This is 3 spaces away from 0. And another way to say how far is the word distance. And in the real world, we don't really use the idea of a negative sign. We use the more idea of how far something away. We don't think of it as a negative number. So when I ask you what is the distance the number 3 is from 0, we can say that's 3 spaces. Or an idea, how far from 0? Or what is the distance from 0? So if I ask you this question, absolute value of 3, how far is 3 from 0? Well, 3 is 3 spaces away from 0. Okay, seems kind of lame. But why is this important for negative signs? Because it kind of messes me up a little bit. Because if I write negative 3 over here, how far is negative 3 away from 0? How far is negative 3 away from 0? Is that also 3 spaces away? Now, I wouldn't say negative 3 spaces. I would just say 3 spaces, because distance isn't negative. Imagine if you're walking to your friend's house, you walk 3 blocks. And when you walk home, do you walk negative 3 blocks? Did you walk backwards for 3 blocks? You don't. So the idea of distance is always a positive number. So if I ask you this next question, what's the absolute value of negative 3? How far is negative 3 away from 0? We would say it's 3 spaces. So we wouldn't use that negative sign. We would just say, hey, it's 3 spaces away, whatever that space is. 3 blocks, 3 miles, 3 feet. So this is the big takeaway of absolute values. It makes everything positive, essentially, because, here's the reason why, because distance, which is what absolute value accounts for, absolute value is actually a big fancy way of saying distance. How far is positive 3 away from 0? Oh, it's 3 spaces, easy. How far is negative 3 away from 0? Oh, that's also 3 spaces. But practically, it really just makes all numbers positive. Okay, let's do this again. So if I give you guys this problem, my example is, what's the absolute value of 10? And what's the absolute value of negative 10? Go ahead and fill those out. How far is 10 away? How far is negative 10 away? So how far is positive 10? That's going to be, we said just going to be a positive 10. How far is negative 10? Well, that's also going to be a positive 10 away. Now, if I draw my number line, just so you guys can see that, I have positive 10 on the right, I have negative 10 on the left. And how many spaces is positive 10 away? That's going to be, 10 spaces. A distance of 10. How far is negative 10? Let's be negative 10. Well, remember, we don't call it negative. It's just 10 spaces also. So that's why they're both positive. Okay, so this might seem pretty easy. Let's do one more, just as a last example. How far is 100 away from 0? How far is negative 100 away from 0? Get out of here. Sorry about that. So how far is 100 away? Well, it's going to be 100 spaces. How far is negative 100? That's 100. Absolute values are that easy. Great. Awesome. Okay. So whether it's positive or negative, it always makes it into a positive. Now, just a reminder, what happens is I don't write absolute value anymore. I just write the number. So you can say how many spaces is 100 away? Well, it's just 100. How many spaces is negative 100 away? That's also just 100. Okay. So here is where it gets a little tricky, because I'm going to ask you this follow-up question. What could x be? Okay, what could x be? If I write this question now, absolute value of x is equal to 100. How many choices do we have? Can you think of 2 points that would be 100 spaces away from 0? 2 points, 100 spaces away from 0. Well, we just did it, right? X could be 100, and X could be negative 100. Thank you. So I'm trying to make this, trying to go backwards. What if I give you another one? What X value would be 3 spaces away from 0? Okay. So that's going to be a positive 3 as well as a negative 3. How are we doing there? Pretty easy? So let's look at it another way. If I have 0 and I want to say, well, what numbers would be 3 spaces away from 0? 1, 2, 3. 1, 2, 3. That's our basic principle. But more practically, this is what I want you guys to do. Whenever you have absolute value, you're going to break yourself into 2 different dimensions, 2 different brand new dimensions. So here we go. You're going to give yourself x is equal to 5 and x is equal to negative 5. You will always break yourself into 2 different versions. So where does negative go? Please notice the negative goes to the non-absolute value sign. And here's the reason why. Essentially, we are saying x is 5 and x is negative 5. Okay, we're saying x is 5 and x is negative 5. Because isn't absolute value of x the same thing as absolute value of 5, which is 5? Absolute value of x is really absolute value of negative 5, which is 5. So we found 2 values that work. Okay, so let's make this slightly harder. What if I write x plus 3 is equal to 5 now? X plus 3 is equal to 5. All right, here's what you do. So we're going to have to somehow get rid of our absolute values. Get rid of our absolute values. And the way we're going to do that is we are going to trade them in for our two dimensions, our two versions. Two dimensions, two versions. So here's what I'm going to do. Please, in your notebook, please draw one line to the left and one line to the right. One line to the left, one line to the right. And we're going to trade in our two absolute value sticks for two different equations. 2 for 2. X plus 3, no absolute value, is equal to our regular 5. Always you'll get the regular version. And then absolute value is gone. We're trading that for x plus 3 is equal to our negative version. Please take a note, guys. There's always going to be two versions here, a positive version and a negative version. Now take a look at the problem. These are two separate problems now. Please understand, these are two separate problems. On my left, how difficult would it be to solve that problem? Have we seen problems like this before? On the right, same question. How difficult would it be to solve for that right problem? So we go through our steps. What variable am I solving for? I'm solving for an x. So the way we get rid of solve for x, we get rid of everything else around it. So we got to get rid of R3 here. So we minus 3 to both sides. So we have x is equal to, whoops, wrong color. X is equal to 2 on one side. On the right side, we're going to do the same idea. We're going to minus 3 to both sides to solve for x. And then x is equal to negative 8. Now these answers don't seem like this would be true. I don't know. How does 2 and negative 8 all of a sudden work? Well, let's go ahead now and check. Absolute value of, we're going to plug in 2. X equals to 2, right? So it's going to be 2 plus 3. Does that equal to 5? On the right, we have x is now negative 8. And then we're going to plus 3. Does this equal to 5? Well, absolute value of 5 is 5. We are good to go there. How about 8 minus negative 8 plus 3 is negative 5 because I have more negatives? True statement? So it turns out there are two answers, two possibilities coming from the left and right side. And we use our algebra to make this problem easy to solve. Let's go back and see, could we have guessed that answer? Could we have guessed that answer? So looking back here, can you think of a number blank plus 3 equals 5? Blank plus 3 equals 5. Most of us would say 2. 2 plus 3 is 5. But would you have thought the other way, that negative 8 would have worked? Because negative 8 plus 3 is negative 5, but absolute values make everything positive. So actually, negative 8 was also an answer. Okay, I want you guys to try this next problem, and I'll walk you guys through it step by step. The absolute value of, let's make this a little harder, 2x plus 4 is equal to, let's say, 10. Okay, absolute value problems. We're going to have two different versions. I want you to draw two arrows, left and right, like we did up here, right? Draw two arrows like we did up here. I want you guys to rewrite the problem without the absolute value. So go ahead, take the first step. You guys take a look at your notes. Exact same steps as before. In order to get rid of the absolute value sign, we can't do math with this. We can't solve algebraically with these walls up, with these borders. So we're going to trade them out. Sell them to the pawn shop. I don't care. But 2x plus 4 is equal to 10. On the right side, we traded in our absolute value signs for a negative version. 2x plus 4 is equal to negative 10. Please be aware and take note that the negative sign always goes to the non-absolute value side. So we have a plus 10 and a negative 10. That's something you have to make like in your brain. A lot of kids will start drawing negative signs everywhere. They'll start drawing negative signs everywhere. Nope. Keep it clean, keep it simple. The negative sign always goes to the other side of the equal sign. The easy side. We want a plus version and a minus version of 10. All right, let's go ahead and solve the problem separately. Go ahead. Why don't you guys take 30 seconds and solve these two problems separately. Okay, if you're done, you guys can go ahead and check your answers. Okay, so let's go ahead and check our answers. We have a 3 on one side and a negative 7 on the other. So let's go ahead and plug in the 3 just to double check. Is it true that x, if it was 3, would make this a true statement? 2 times 3 plus 4, which is equal to 10. 6 plus 4 is 10, and the absolute value of 10 is 10. Whoops. Yep, that worked out. On the right side, this one seems like a bigger number. 2 times negative 7 plus 4. Is this equal to 10? Negative 14 plus 4. And I have more negatives here. Negative 14 plus 10. I have more negatives. So we are going to end up with negative 10. And is the absolute value of 10. Remember, absolute value makes everything positive. Yeah, that is 10. We found both the different answers. Now, just to go one more step here, what if I want to graph this solution? To graph the solution, we said x was equal to 2 answers here. That's my x and that's my x. So on a number line, x is negative 7, put a solid dot, because x is equal to negative 7, and x is 3 on the number line. So all you have to do is put a dot on both. On the IXL problems today, you guys will be these separately. You will be one solving. That's one activity. And the second activity is graphing your absolute values. If you look at the note, the IXL for solving, that'll be up to 90, smart score of 90. And the graphing, I think, was going to be like 50. And you can double check in the material section. Okay, so here is the main idea. If you have absolute value symbols, we trade them for a positive and negative version. We can't do math inside the walls. Think of this as a Great Wall of China. We can't attack till the wall comes down, okay? So I need to get rid of the walls first before I can do any math. So I get rid of the walls by trading them for a plus and a minus version. Now, I'm going to put some numbers outside this great wall now, these absolute value walls. So here is my next version. Absolute value of, let's say, x plus 4 minus 3 is equal to, let's use the number 9. So I want you to see this problem a little different. You cannot get rid of the walls. You can't get rid of these. Why? What's waiting outside those walls? Do you guys see this intruder here, this negative 3 here? Okay. So here is the strategy for this problem. You cannot get rid of absolute values unless the problem is alone. If you look at our problems previously, the absolute value is alone on its own side. There are no numbers outside the absolute values. So we can't trade until we're safe. So what we're going to have to do here is to get rid of this -3 first. Okay, so please notice the absolute value isn't safe. The -3 is there. So we have to use our algebra skills to get rid of that -3 first before we can trade out our absolute value sign. So you're going to get rid of this -3. How can I get rid of a -3? +3 to both sides. And this is the math step that we practiced before. We can do this. We're not breaking any rules. If I add 3 to one side, I add 3 to the other. Gone. We are left with absolute value of x plus 4 is equal to 12. Now, please notice, this is important notice. Now that the absolute value signs are alone, now we can trade. So let's draw our 2 arrows, and I want to give you guys just 10 seconds. Please write down my 2 different versions. Hopefully you wrote x plus 4. Remember, the inside value doesn't change, right? The walls come down, but the people inside are still safe. They're still safe. What changes is the other side. So this 12 becomes a positive 12 and a negative 12. And then our next step is just to solve the problem separately. This becomes 2 easier equations. -4, -4. But guess what? You're going to do the exact same steps on the other side. X is equal to 8. X is equal to, okay, -12 minus 4. You owe me $12 and you owe me 4 more. You owe me a lot of money. You owe me 16 bucks. If you want to graph this, draw a number line. We said X can be 8. And we said X can be -16. We only have 2 possible answers here. This isn't like inequalities. Only these 2 answers are going to make the problem true. Okay, so let's recap one more time. Whenever you see an absolute value problem, yeah, we're going to get rid of the absolute values. But if there's stuff outside of it, you must get rid of it first. You cannot do the trick of splitting an absolute value if there is stuff on the outside. It has to be pure. See, this is a pure absolute value problem. Now we can split it. If there's stuff on the outside, you cannot split it. Don't even try it. Clean up the room first. Okay, set it up. Let's do one more. It'll be 2 absolute value of x plus 3, absolute value of -4 is equal to, let's do 16. A question was, do the results turn positive? No. What happens is we are not using the absolute value. We are trying to figure out what would work to solve this absolute value problem. So back here real quick, if I plug in 8, would you agree 8 plus 4 is 12? And the absolute value of 12 is 12. That works. And then -16 is my other answer. -16 plus 4 gives me -12. And the absolute value of -12 is going to be a positive 12. So our x answers can be negative, and it doesn't change till we're done plugging it in. And then we apply the absolute value, which makes it positive. So the x answers can be negative. I'm not saying absolute value of -16. I'm not saying that. My answer is -16. In order to get this to become 9, I would have to use -16. Not a positive 16, a -16. Okay, let's try the next problem. I see, okay, here's my Great Wall. Right? So I can't open up the gates. I can't bring down the walls unless if I get rid of everyone on the outside. So this problem could look like, just on the side, this could look like 2x minus 4 is equal to 16. Right? Think of it as this type of problem. What number do we get rid of first, the 2 or the 4? We practiced before. We get rid of the, what's farthest away? The 4. Add 4 to both sides. And then we get rid of the 2. So that's the plan. Get rid of the 4, then get rid of the 2. So over here, let's go ahead and do that. We cannot touch the absolute value. That's almost like a fortress. So we have to get rid of all the numbers on the outside first. Okay, let me pause here to make sure we all saw what we did. I got rid of the 4. I saw that was the farthest away. That was the easiest value. Negative 4 plus 4 cancels out to become 0. I don't write that, but we can see what happened. We're still left with the 2. The 2 hasn't gone away yet, right? We're just copying it down. And 16 plus 4 is the 20 we wanted. Now let's get rid of the 2. What is the 2 doing to the absolute value sign? When numbers are next to a variable, next to an object, it's multiplication. So the opposite of multiply is divide. So we're going to divide both sides by 2. 2 divided by 2, cancel out. Please notice that. 2 divided by 2, cancel out. And then we're left with a nice absolute value of 3. X plus 3 is equal to 20 divided by 2 is 10. Got one step left. Okay, now that the absolute value is by itself, now it's a pure problem. This is the only time you can trade out an absolute value, when it's cleaned up, when it's by itself. You guys ever try to sell something? Like maybe sell an old Xbox, maybe a Game Boy, or maybe an old cell phone? Do you sell it as is? Don't you want to clean it up a little bit? You can think of it as, here's the dust, here's the watermarks, the fingerprints. You want to get rid of all of it before you sell it. Now it's a pure absolute value problem. And with pure absolute value problems, we trade them for two versions. Let's draw our two versions. We have x plus 3 is equal to the easy. You're always going to have one that looks just like the problem without the absolute value sign. X plus 3 equals 10. That's always a freebie. Okay? Always at least get the freebie right. And then the next one is x plus 3 is equal to negative 10. Again, think of the wall falling. The people inside are safe, right? They're going to be totally safe. So the negative always goes on to the other side. Minus 3 to both sides. To solve for x, our first answer is 7. And our next answer is negative 13. Because negative 10 minus 3 is negative 13. You owe me 10. You owe me 3 more. You owe me 13 bucks. You owe me a lot. Okay, let me pause here. So, do we always have an answer? Let me ask you this question. Absolute value of x is 5. What do absolute values do? It makes everything positive, okay? So our answers here, if I plug in, so let's go the other way. If I plug in negative 5 or 5, that would kick out a 5, okay? Absolute value of negative 5, that's equal to 5. Absolute value of 5, equal to 5. It makes everything positive. But if you ever see a problem that does this is a bad, okay? Absolute value of x equals to negative 3. Wait a minute. You just told me absolute value makes everything positive. How come you're trying to tell me it's a negative now? And the answer is no solution. There is no answer to this. This is like a dumb question. Hey, what number of an absolute value would make it negative? And we just said absolute values always make numbers positive. So this is no solution because this is never going to work. Let's try it. If I try a 3, is the absolute value of 3 going to become positive or negative? Isn't this going to be positive? So that is not true. But let's go, try the negative version. Fine. See, negative is negative. Nope, because absolute value makes everything positive, and it does not make it negative, so they are not true again. Okay, so what happens is, here is a trick question, and this is a question that you might see on the SATs, because oftentimes it's full of trick questions, is that an absolute value can never equal to a negative answer. What I mean is, this original statement cannot be negative. Sure, the inside x could be negative, but the overall answer after the absolute value cannot be negative. You can almost think like the absolute value makes the number pure. It cleans it up, makes it holy. So if I plug in a -5 or a 5, it makes it holy 5. But this one here, something broke. So there's no solution there. Okay. So let me give you another trick question. If I say x plus 2 minus, plus 5 is equal to 3. So the way we would start this problem is go ahead and try to get the absolute value by itself. So we have to get rid of the 5. So I minus 5 to both sides, opposite operations. I'm going to rewrite it. Now, is this possible? Can the absolute value ever become negative? Answer is no. So that's a no solution. So the trick is, we might start off as positive on both sides, but once I simplify it, we realize this is not true anymore. So there's no solution. Okay. And there's only one time. So we have, our answers are either 2 solutions, no solutions, and there's only one time it'll be 1 solution, and that's when x is equal to 0. Okay, that's the only time we end up with 1 solution. Positive 0 and negative 0 is the same thing. Okay, to rewrite this out, we can try trading the absolute value sign for a positive version and a negative version, and these are both the same thing. That's the only time we have 1 solution. Okay, so on the IXL, they will be asking you, hey, are there any solutions to this problem? Okay, so they will mix it up, not only solving, but then they'll ask you, are there any solutions, 2 solutions, 1 solutions, or no solutions? Okay, and that's it.